very warm welcome again to everybody who's joining us from across the globe. And it's wonderful to see that we indeed do have a sprinkling of people from everywhere. And very quickly, I'm Professor Naveen Joseph Thomas. I'm the Vice Dean at the School of Government and Public Policy, and I've played an important role in shaping the Masters in Public Policy online, which is part of one of our flagship programs at the OP Jindal Global University and our school, the Jindal School of Government and Public Policy. Today with us, we have Professor Krishanu Karmakar. He is professor and the Associate Dean for Academics at the School of Government and Public Policy. He is an avid public policy researcher, has very varied interests, and he actually teaches the public finance course in the program. Today, he's going to share some interesting insights on his pet interest areas, that's data visualization and data analysis. Professor Karmakar, although he teaches public finance on the online, he does that in the residential mode as well. But he also has very keen interest and takes he takes several of the data analytics courses for our masters in public policy students in our residential mode. It'll be great to get some of his insights into data visualization. Very briefly, Professor Karmakar has his PhD in public policy from Georgia State University. And before his PhD in public policy, he holds a master's in economics from the Delhi School of Economics. Without further ado, I'll pass over the mic to Professor Krishanu. We are in your good hands to lead us into this session.
Thank you, Naveen. Thank you for such a kind and elaborate introduction to my past. And welcome, everyone. I hope this 1 hour will be very interactive and useful for you, because I can see many people are joining from almost the other side of the world. So it is very early morning, I guess, there. So yes, data is something that is very close to my heart. Therefore, when Naveen told me to take a session on data visualization, I almost jumped at it. So what I have planned to do today is talk about the principles and a little bit of the theories behind data visualization, because most of the time when we see data, we jump into it without thinking much further. But today means in 2026, we can see that data visualization has become almost a sub-discipline of statistics and informatics. Well, we will not get into informatics as such. We will stick to statistical graphics and the principles that govern them. So first, we have to understand what is data visualization. And once I describe and define what is data visualization from a very abstract point of view, what I will do is I will take you to all of you through Excel and create one visualization first, because I think that will make you interested in the theories behind it. And once we have created that particular visualization, then I will get into why I created that visualization in that particular way. So instead of trying to discuss the very dry theories at the very beginning, I will first give the example and then try to discuss why the example is as it is based on the theories and principles. So I hope that will be a novel and interesting way of approaching this session. So a visualization is basically a visual mode of communication where numbers are encoded in symbols and geometric shapes to coherently and consistently, that must be done coherently and consistently, to enable discovery, because there is always something that we do not see per se just by looking at the data, which is hiding in the data, some truth about the real world. So to enable discovery, and also to enable analysis, and of course finally to convey some meaning and some stories, because that is what data visualization is all about. So that is what data visualization is. It is encoding numbers that represent the world in geometric shapes. So for example, take this diagram or take this graph. What does it show us? It shows us some fictitious data. I have based this diagram on some fictitious data about users of some particular service over a particular week. Now, as you can see, the numbers have been encoded in the length of these bars. So the bars are the geometric shapes that I was talking about, the rectangular shapes. The bars are ultimately rectangles. And the shapes of the bars, the height of the bars represent the numbers. Not only that, I have tried to also in this diagram highlight a particular day of the week, which is Saturday, but that is not being highlighted because it is Saturday. It is being highlighted because it is the highest number of users of that particular service for this week belong to Saturday. Now, as you can see, this very clearly displays some information. This is a visual mode of communication showing some story. Now let's create this diagram in Excel. All right. So let me move over to Excel and let's create it all together. I am assuming that all of you have access to Excel. So it will be great if you can do it with me. All right. So let me first show you the actual data. I am assuming the font size is large enough so that all of you can easily see them. So go ahead and type the data in an Excel worksheet as it is, and I will wait for you for a little bit because I think it will take maybe at most 1 or 2 minutes. So go ahead, type the data as it is. So there are two columns, A and B. My data actually starts from the cell A3 as such. So the column A has the days of the week, and column B has the number of users. And at the top, I also have one kind of statement written which says number of users per week. So that all of these things we will need when we create that particular visualization. So go ahead, type it in. Then I will take it from there. Now remember one thing, when we create a graph or a diagram in any software, it is not necessary that we use just the raw data. Most of the time we have to process the data to take it to a form or bring it to a form which will give us the visualization that we want. And you will see that I will not just use this raw data as it is. I shall add several columns here which will aid me in creating that particular diagram that I showed you earlier in my slide. So if you still remember, let me just show you for one moment the diagram that we want. So here, what do we have? We have several things. Number one is the first of all the bars, which are the numbers that you saw. These bars will be based on those numbers. But at the same time, I have the weekdays written at the bottom of the bars. And also I have the numbers, that the number of users written at the top as the label, data labels. Now, you might, as I will discuss later, that sometimes these data labels are not necessary. But in this case, I am adding them. There is another third element, and that is one of the bars is colored differently. So keep these things in mind because this will be important. And based on this, we need to modify the data a little bit. So first of all, I need the maximum of the week, and I'm not going to just create a static maximum number. I want to create this graph in such a way that if I have to change the underlying data and if the highest number of users falls on another day instead of Saturday for a particular week, that can be accommodated without doing any modification to the graph. So we will do that. So let's first add a heading here in the cell C2. and the heading is maximum. Just simply max. Or you can say max user, is up to you. Now, I'm not going to just calculate just put the maximum by visual calculation. I'm going to use a status function. So I'm going to use the if function. So let's start with if, and if the corresponding cell under the column B is equal to maximum of this range, and let's fix that range using the dollarization, then comma, then this cell should return this user number. If it is not equal to the maximum number, then this cell should return the not applicable or not basically the missing value function of Excel. So if any of you need a little bit more explanation of this function, please raise your hand, and I think I shall be able to see that in the chat box. So I will go ahead and explain it a little bit more in that case. Otherwise, I shall go ahead with it as it is. So just very briefly, I'm using the if function of Excel, and I'm asking Excel to return me the cell B, corresponding cell in the B columns number, if that is maximum of the range. Otherwise, just return missing. So as you can probably visually see, because there are only 7 numbers, 400 is definitely not the maximum. So the returned number should be the missing value. So if I press enter now, it is the missing value. So now let's drag this cell. And as you can see, 800 is the maximum, and that is the only cell in this column which is being populated by the number. All the other cells are NA.
Krishanu, would it
Yes.
be possible for you to drop the command onto the chat box?
Yeah, sure. Absolutely sure. Just let me copy it from here. And thank you for that idea. Here you go. Now, assuming that you have typed the data exactly I have in the exact same cells, this function should work for you. Not only that, I am going to also copy or clone the users column as users2. Now, this is just a clone of that same column. So it is nothing, just equal to B3. I am entering that as well very soon in the chat box, but let me just do it first. So this users column is just a clone of the user column. Users2 is just same as user. So that is, I have entered equal to B3 in the column, in the cell D3, and then I dragged the formula. Now let's try to the insert chart facility of Excel, because this is what we are going to use as our data for creating this chart. So select the data. Don't select the number of users per week cell yet. So select the data from A2 up to D9 and go to insert. In the insert, go to the charts facility, and there select 2D column charts. So we are going to select 2D column charts. And right now the diagram will not look anything like what I showed you earlier. So after clicking on the 2D chart, this diagram should come. Now this is nowhere close to what I showed you earlier. So what you need to do first is click on just once on any of these bars. So after selecting, right click on them, and this uh, menu should appear if you right click. I'm assuming all of you have been able to reach up to this stage. All of you are with me, I hope. If not, feel free to raise your hand. Now let's go to the bottommost item in this menu, which is the format data series. So if you click on format data series, on the right hand side, this format data series facility comes up. And hopefully right now you can see there is something called series overlap and something called gap width. We will change these values. We did not use any formula for column B. Uh, column B is the raw data. So 400, 300, 450, these are all numbers that I entered by typing. The formula that I used were in the column C and the column D. The first formula that I copied and pasted in the dialog box, sorry, not dialog box, the chat box. It is somewhere up. So just scroll up a little. You can see the formula. The big formula is in column C. Let me just put it once more. Just hold on. Oh, you have, okay, thank you. Thanks, Naveen. And no, not that. In column D, I have simply put equal to B3 and then dragged it. I just copied the entire, basically I created a clone for that column B in column D. All right. Okay. So now after selecting this, any of the columns just once, make sure that you select it only once and right click on it. After that, go to the format data series and this format data series facility comes up. There in the series overlap field, make it 100%. So just type 100 and then in the gap width, type 75. So in the series overlap, we are typing 100. Whatever there is, doesn't matter. Type 100, replace it by 100 and gap width replace by 75. So what that will do, that will first of all make all the three columns overlap each other. Now you can only see one column on each day. And also it will make the columns thicker and the gaps narrower between them. That's what it's going to do. Now let's say I want to make them gray, so let's change the color. If you want to keep it green, that's fine. That's perfectly fine. Let's now just delete the legend. We do not need the legend. At the bottom, you should see probably a legend comes up. We do not need that. So let's just select that legend here. This is the legend of the chart. And let's just delete it. All right. Now what I'm going to do is, now I'm going to select this column once more, any one of them, right click on that, and in the menu that comes up, go for add data labels. In the column C, you can see that Professor Naveen has just above your comment, Professor Naveen has copied the formula in the chat box. So you can copy it from there and paste it. So add data label. And if I click on add data label, the numbers appear on top of the bars. I also want to do something more. So what I want to do is I'm going to now select these numbers because I don't want the Monday, Tuesday, Wednesday, Thursday to appear below the bars. I want them inside the bars. So what I'm going to do is just select any of these numbers and you will see on the right hand side, instead of format data series, it will come as format data labels. What happened? Um, so there, okay, let me just stop here a little. Can you guys see the formula now? Ah, um, okay, yeah. Naveen, I think it was initially copied to the only the panelists and hosts. I don't know how to do that. How do you do that really? I don't know. Anyway, it's good that all of you can see it now. Professor Naveen has copied it to everybody. So now select these data labels. That is these numbers that have just now appeared at the top of the bars. And since the format data series was already active on the right hand side, that will be changed to format data labels. There, click on this the icon that looks like bars. And now you can use different any of these different variables or columns instead of these numbers. So right now it should show value, and it also says show leader lines. So I'm going to suppress the values and the numbers goes away. What I rather need are those date or sorry, the names of the days. And the names of the days are basically category names, because in Excel's parlance, the values of the this horizontal axis variable are the categories. So what I've done is I have put the category names in case of label options, label contents. But still, the labels come at the top of the bars and outside. I want them at the bottom inside the bars. So what I'm going to do is, in the label position, I'm going to select, instead of outside end, I'm going to select inside base. And the names of the days goes to the bottom of the columns. Then what I'm going to do is I'm just going to, since the names of the weeks, the days of the week are still selected, I'm going to just change the font color to white. So you can change the font color by going to the font tab in the home ribbon. So now the days of the week comes at the bottom of the, or in bottom inside of the bars. Now what we are going to do is, now we are going to select this diagram, right click on the diagram itself. And in the really big menu that appears, go and click on select data. Now in the select data dialog box, you will see that the three series that we have, users, max and users 2, are put in a certain order. Now this actually creates which series comes on top of which. So what I'm going to do is I'm going to take the max series and put it at the very, actually the bottom is the frontmost. So what I'm going to do is I'm going to select this max series, use this bottom arrow and bring it in front. So it is, the order is like this. So now users is at the top, users 2 in the window, it looks like it is on the top, users 2 is just below it, and max is at the bottom. Exactly the opposite thing happens in the diagram. That is, max is actually in the front right now, and the users series is at the very back end. So it's like transparencies, one on top of the other. The one that is at the very bottom is the transparency which is at the top right now. So after this, what I'm going to do is I'm going to just say, just for the time being, I'm just going to say okay. And as you can see, since I have put that max bar at the top, the max series at the top, that has used a different color and it is now in front of you. All right. Now there are, very soon I will be explaining to you that duplication of information is completely unnecessary in graphs. So what I'm going to do is I'm going to delete the horizontal day names. So I'm going to delete, select, just click on any of these Monday, Tuesday on the horizontal axis and press delete. The horizontal axis will go away. Click on any of these horizontal grid lines and press delete. They will go away and make it cleaner. Go to the chart title. If you do not have chart title right now in your chart, what you can do is select the chart, go to chart design. In chart design, go to add chart element, and there you can add chart title. So if you do not have by default in this particular chart, the chart title appearing at the top, this is how you can add the chart title. Select the diagram, go to chart design, then go to add chart element and there add chart title. Now we are not going to type the chart title in the chart manually. Rather, we will make it dynamic so that if we need to make the chart title different, it is automatically changed. So what will you do? We will select this cell, go to the address field, type equal to, and then select the cell A1. Someone has a question. Um, Okay, yeah, you can use your headphone to listen to what I'm doing. I mean, there are several ways. You can side by side in your screen, keep Excel open and listen to what I'm telling you and do it as well. Or you can just listen to me and keep on doing along with that. And someone wanted to write something but didn't finish. So I do not
In any
know.
case, if this will be the session is being recorded, and it'll be available on our MAPP on MA Public Policy online landing page on Coursera. So you can access it there in a day or so, in case you want to go back to all of these steps. Yeah.
So you add a chart by selecting the data and then going to insert chart. That's how you add a chart. All right. So now, um, what did I tell you is that let's select the chart title. After you have selected the chart title and make it activated. Go to the address bar, press equal to, and then click on that cell A1 where you had typed number of users per week. So you should see that now in the address bar, there is a cell reference. So now press enter and your chart title will be changed. Now, what is the benefit of doing this chart in this way? Let's say your data suddenly changed and instead of it may be that you have got now corrected data and you see that on Tuesday, instead of 300, actually the number of users was 1300. So you had to change the data. So let's change the data and let's see what happens. So now automatically your maximum number of user belongs to Tuesday, and therefore your chart automatically gets changed as well. Let's say instead of that, that data was, let's say, correct, but let's say Thursday should be corrected to 900. You press enter and the data gets changed as well. So this is the reason I created this chart in this particular way. The other parts of the chart that I have used will be clear after I discuss the theoretical points that I want to talk about. So let me wait here for a minute or so and let's see if there is any question that you guys have about this chart, how to create or something in particular. Then I shall move on to the discussion of the principles of data visualization. So I'm waiting to see if there is any question. Let me just scroll through to see if there's anything. Um, I'm not sure what you mean by the previous chart as such. Which one you are referring to is not very clear to me. So if you want more discussion on that, please go ahead and type your question once more I mean, what exactly do you mean? I'm sorry, but I don't understand French, so I'm not sure what this question. If you have a question, is anything? No, I don't think there is any other question. Bar chart I showed you first means, do you mean that chart on my PPT? This is the same one. That's what I'm showing you how to create. It's just that I had also changed the bar colors to gray here just to save some time. I'm not changing the color from default green to something else. If you want to change the bar color, that is doable pretty easily. So there is no difference as such. I'm actually showing you how to create that color. There is another question. Why did I select this chart? Uh, that's just because I needed some chart to as an example. That's it. What I mean that so I more days with my success. Yes, absolutely right. If a different day has maximum number of users, dynamically this chart will change to that if you change the data in the users column. So whichever day is now the maximum number of users, that will change. So you can put in another week's data here, copy and paste it just in the users column, and your diagram will change. Um, Chart title. So let's go back again. Let's delete this chart title altogether. I do not have any chart title at all. So select the chart, go to chart design. In chart design, go to add chart element. In the chart element, I'm going to go and add chart title. I'm going to add a chart title above the chart. So I select that option, and this blank chart title with just the word chart title comes in, which is now selected. So let's just select it and go to the address bar of or functions bar, whatever you call it in Excel, and there enter equal to. And after that, we had already typed the phrase numbers of users per week in the cell A1. So I'm going to just select that A1 cell. So your address bar should read the reference to that cell right now. So then you can just press enter and your chart title will be automatically created. Now, what is the benefit of that? Instead of typing it inside the chart, that I can change this thing to anything, A, B, 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 and your chart title will change. Well, that makes no sense, but still you get the point that you can change it here in the cell A1 and your chart title will change automatically. All right. Well, edit, yes, that can be done, but that was not the point of this particular chart. This was a particular chart I wanted to create in this particular way with just one message here. And that message is these are the users during the week, these are the number of users during the week, and this particular day of the week is the maximum. What you are talking about is comparing with another week. That will be a different chart. The cloned column was actually used because I actually did not use it properly, honestly. If I wanted the original graph that I created to show you, you can see that not only I have the Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday at the bottom of the bars, but also the number of users of a particular day just above the bars as data label. So if you want to do that, then you need the cloned column. So for that, what you can do is select that's a good point. I forgot about that. Select the chart, go to select data, and then deactivate users and max. So now you have that only that cloned column users too. Press OK, and well, this one has used the users 2 itself has used the Monday, Tuesday. Okay. So go back to the chart again, go to select data, select users and deselect users 2 and press on OK. Now you can see the Monday, Tuesday is no longer there in these bars. That's because the Monday, Tuesday were data labels for the users 2 column. So I want to put the numbers of users as data labels to this particular series. So select any of the bars, right click on it, add data label, and the number of the the number of users for each particular day comes up. Once you have added the number of users for each particular day in the chart itself, there is no point of keeping the vertical axis. So I can now select the vertical axis and delete it to make the diagram even neater. So now I'm going to select the chart again, select data, and activate all the series back again. So we can see all the series together now. So now see the difference. Now, one of the series, which is actually the users 2 series, is basically the green one that you can see. The blue one, which is the user series, is behind it. You cannot see it. But what you can see there from that series are those 400, 400, 300, 450 data labels. The Monday, Tuesday, Wednesday is actually are the data labels for the users 2 series, which is the green columns. And that is how you are seeing that. And the orange column is basically coming from the max series. All right. So that is how it all went. Any other question? Okay. Then let me try to very briefly discuss why I did things the way that we did. So what are the different parts of a visualization? A visualization basically consists of two things. One is the encoding part, that is the numbers encoded in geometric shapes and different types of attributes of geometric shapes. And the second is the scaffolding that holds up the chart. So what is the encoding part? In this particular example on the slide that you can see, these bars, the rectangular bars that represent the data is basically the encoding. We are encoding the numbers in the height of these bars. What are the scaffolding part? Everything else is scaffolding. The title is scaffolding, the subtitle is scaffolding, the vertical axis, the legend, the horizontal axis, the scale of the axis, and also if I had a source of the data written at the bottom of the chart, that would also be scaffolding. So all these two type of things, one is the encoding part and another is the scaffolding part, creates a visualization. Now, there are certain principles based on which we need to use this. And what are these? And why do we need to follow some principles? We need to follow some principles because of, first of all, you need to understand what is a diagram. A diagram is basically, we are trying to show values or differences in values, which or the pattern in the values, which are encoded in the attributes of some geometric shapes. It might be the length of the bars. It might be the size of a circle. It might be the thickness of an area. It might be the distance of 2 points. So these are the attributes of these geometric shapes. That is how we create diagrams. But there is a fundamental, actually there are two fundamental problems there, which are the fundamental problems of data visualization. What are the two fundamental problems? The first fundamental problem is someone creates the chart, someone creates the diagram. Let's call him or her the creator. So the creator, what does the creator do? Encodes these numbers into some geometric shapes. All right. And then that chart or the diagram is seen or read by the audience. So the first problem is that there is no other mode of communication between the creator and the audience. When the audience will look at the output of the creator's work, the creator is no longer there to explain what she or he has done. Therefore, the audience must read the chart without any further interaction with the creator. Therefore, the creator must, an audience, what the audience is trying to do? Audience is trying to read the chart to decipher some meaning. Now, there are two possibilities, right? When you are trying to decipher some meaning, either you might be able to correctly decipher the meaning or wrongly. So there might be some error and there might be some part that you are doing it correctly. Since the creator has no other way of communicating with the um, audience. It is only that chart that is there as a mode of communication between the audience and the creator. It is the task of the creator to minimize the possibility of error on part of the audience. Otherwise, the error will be large and the story or the message that the creator is trying to convey will be lost. Therefore, that is why the creator must follow certain conventions. These conventions are sometimes statistical in nature, sometimes they are social in nature, because that is how the audience will read. Based on those conventions, the audience will read the chart. So, this is the fundamental problem of data visualization, that there is no, when the audience is reading that chart, the creator is no longer there. And another thing is that the creator also need to correctly encode the values. So these are the two fundamental problems of data visualization. Now, I was talking earlier about the attributes of geometric shapes which the creator uses to encode numbers. Now, what is this? What are these attributes, and what are the conventions that I was talking as well about as well? So these attributes, so if you think of any geometric shape, what are the geometric shapes that we encounter in our regular day-to-day life? It can be a rectangle, it can be a square, it can be a circle, it can be a part of a circle, basically a piece of a pie. What else? It can be just a line, it can be a dot. So these are in two dimension. I'm not getting into three dimension. These are the two dimensional common geometric shapes that you encounter. But each of these geometric shapes, what are the attributes that they have? Just think of the rectangle. It has, on one side, you can think of it, it has a length and it has a width. So length is one attribute, width is another attribute. In case of a triangle, or in case of a piece of a pie, it is the angle that is also the one of the attributes. Then you have any shape is oriented in a particular way. That is another attribute. Its size, its shape, and whether it is put inside any bounded region. These are the attributes. Now, you as creators of these diagrams, what you will do, you will use these attributes to represent, that is to encode numbers. Now the thing is that some of these attributes are good in doing certain things, some of these attributes are not good in certain other things. For example, on the slide you can see that some of these attributes are good at conveying quantitative messages, some of them are good at conveying qualitative messages. Two other types of other sets of attributes are also the hue and intensity, which in common parlance we talk about color. So color is also another type of attribute. Actually, color has two different attributes. One is the hue itself, another is the intensity of that hue or the saturation of that hue. So this is another attribute of geometric shapes that we can use. And finally, the relative position of these geometric shapes in two dimension. So what do I mean by that? Just think of, I'm just assuming that many of you have seen scatter plots. So what is a scatter plot? It is basically a lot of small circles placed in a two-dimensional space. Now, the two-dimensional relative position of those circles represent the change in the data values. That is what a scatter plot is. So these are the attributes that are used by diagram or chart or data visualization creators to represent different types of quantitative messages. Now, what are the three types of quantitative messages that we might want to convey? Usually, there are other types of rarely conveyed messages as well, but what are the more popular three main types of quantitative messages that we might want to represent through these diagrams or communicate through these diagrams? One is the quantity by category message. That is, we have some values as we just show, different number of users over different days. It may be different number of let's say different GDP for 2 3 different countries or regions of a country. So these are quantity by category message. Next is quantity by time. That is how a quantity changes over time. So a GDP for a particular country or a particular region over some years. So that is quantity by time. And finally, quantity by quantity. So the things that we try to represent by scatter plots, that is the relationship between two different variables, GDP and employment level, GDP and let's say uh, level of pollution of different countries. So those are quantity by quantity, quantitative messages that we might want to convey through our diagrams. Now, what are the different sub messages, or how can we go to a little bit more granular differentiation within each of them? So even when we are trying to represent quantity by category, there can be three different types of messages that is the at the heart of our data story. One is the difference in the values. Second is the ranking of the different categories based on the values. And the third is the part to whole. That is how a value corresponds to the total of the whole thing. Similarly, quantity by time can also have three different types of messages. Difference between difference across different time periods, pattern over the entire time period, or how each of the time periods value constitutes the whole. What is its importance in the total? So that is the part to whole. And finally, quantity by quantity is what is the overall pattern between or relationship between these two variables or quantities. So these are the three main types of quantitative messages we might want to convey through these diagrams. Now, I told you that earlier we saw in a slide that different types of attributes are good at representing different types of quantitative messages. So let's see which type of these messages can be well represented or well documented or well encoded by which type of attribute. Let's see that. First of all, quantitative value and their differences. So, what was the first type of attribute that I showed you earlier when I listed all the attributes? That was length. So, what is length good at? Length is very good at representing the difference in value. First of all, representing the value itself and difference in value. That is represented very well by length. So next is angle and the difference in angles. So the difference in angle is also very good at, not very good at, I would say, but as long as the number of categories is small, it is quite okay representing the difference in value. Then the size of the geometric shapes, they can also represent the difference in quantitative values. So usually we take bigger sized objects to represent bigger values and smaller sized objects to represent smaller values. Next comes color and intensity. Now this is very well used in making maps, heat map type of things, where the color can be used to represent how the values are differing. So for example, look at the bottom two examples, the blue one and the brown one. Most likely, without any further explanation, you will understand that I am trying to represent some quantitative value becoming smaller and smaller. So the difference in the hue and difference in rather here it is actually the difference in saturation is representing the difference in value of some underlying variable. And finally, the shape and difference in shape. So for example, we can use different types of objects to represent different values. However, I told you also that Not all of these attributes are good at representing all of them. There is a relative ranking between these attributes. And what is that relative ranking? So if we think carefully, we'll see that as we go up this ladder, the higher is the item or higher is the attribute in this ladder, the better it is in representing the difference in value and difference in value. And the lower we come down, the worse it becomes. So length and difference in length is very good at representing difference in values, but shape and difference in shape is not that great. So one type of message is value and difference in it. The second type of message that I had was quantitative message I had was pattern. So what are the attributes which are good at showing patterns? First of all is length. Think about line charts, timeline charts. So the line represents the pattern. But at the same time, we do not need the line to be continuous. Our eyes are good enough that we can make the discontinuous lines seem continuous or read them as continuous as well. So length of something helps us represent the pattern. Then 2D position of the items also helps us represent pattern. For example, this will most likely you will interpret this as something going down. So the pattern is that the relationship is going down or the value is coming down. Then is color and intensity. Going back to the earlier example, this again shows how the whatever value it is changing from left to right in both cases. The intensity is either going down or the intensity is going up. And finally, width. So sometimes we also use width to represent the pattern, but again, not all of these attributes are good at representing these differences. So again, there is a relative ranking. The length is pretty good at doing it. Width are not that great. So this is how we can encode patterns into geometric shapes and their other characteristics. Finally comes categorizing, because that also is important in categorizing, highlighting, and grouping. So the first thing that we might use are hue and saturation. So here, look at here. The top portion is that if you have created a table, let's say, and you want your audience to read the table column wise, you do not need to use any other visual cue other than just changing the intensity of the color uh, for each column. And your eyes, our human eyes, are such that it will go across along the columns first. So we will not try to read it through rows, but rather column wise. So that is how we can use hue and saturation. Secondly, the graph that we just created, something in abstract sense, is like the one that you can see at the bottom of the screen right now. Here also, I am using the hue, a different hue, the brown color, to represent, highlight that particular data point. So hue and saturation can be used to categorize things very easily. Then is enclosure. That is, if you want to categorize things, you can put them into enclosure. Now, the enclosure need not have a very stark boundary like the left side diagram. It can also have something like the right side one. So both are possible. So if you want to categorize and group things or highlight things, you can use enclosure as well. That is another attribute, of course. You can use 2D size as well. So you can use two different sizes to group things or to show the difference in grouping. Then there is shape. So again, there are two different types of things that is probably easily decipherable by most of you. That is, we have one group of things which are circles, another group which are represented by squares. And finally, orientation. So all of the other bars are vertical except one is oblique. So that also tells us that something is different for that oblique bar. But then again, all of these items in this list are not good at not equally good at representing categorization and grouping. As we go up above this ladder, we see that the items or the attributes become better and better and better in doing categorization and grouping. And the lower we come down this ladder, the worse it gets. Naveen, do I have to
Sure.
stop now because we are already 7?
Yeah, I think let's try and wrap up
Okay.
rather than finish abruptly, and you can wrap this up and then we can close.
So I will just finish it here. That let's go back to that earlier thing that I talked about. So bring everything together. So there can be three types of messages: quantity by category, quantity by time, and quantity by quantity. Now, under them, there were three different sub-messages: difference, ranking, part to whole, pattern, part to whole, and difference, and finally pattern. So what are the common diagrams that we can create using the different attributes and geometric shapes that I have discussed? So difference is shown very well by bar chart. So again, remember, there are thousands of different types of charts possible. I am only talking about very popular and commonly used ones. So bar chart and pie chart. Bar chart uses length, pie chart uses the angle to show the difference. Ordered bar chart, pie chart shows you ranking of different items. Stacked bar chart shows you part to whole. So that is what when the message is quantity by category. When the message is quantity by time, we can use line chart to represent pattern, stacked bar chart to represent pattern, part to whole stories, and bar charts again to show the difference. Finally, when you are trying to show quantity by quantity items, we can show that the story is the message is quantity by quantity comparison and the pattern in that relationship, we can use scatter plot. So this is basically the kind of the theory in a very short time period of data visualization. So data visualization is ultimately encoding of numbers in geometric shapes and their attributes. What are the attributes? These are the attributes. Some attributes are good at representing certain types of messages. Some attributes are not good. So what you need to take it from this talk is this, that not all types of attributes are created equally. Some are better at certain types of messages and they are worse at some other types of messages, while some other attributes are good at those other types of messages but not good at what this first group could do. Therefore, depending on that, you need to use very judiciously these different types of attributes to create your visualization so that you can overcome that fundamental problem of data visualization, that is communicating what you wanted to communicate without error to your audience, because that is ultimately what we all want to achieve. All right, so I shall stop here. Thank you for listening to me. Over to you, Naveen.
Thank you, Professor Krishanu, for so adeptly taking us through the 101s of data visualization. I think we'll have time for one or two questions. Let me very quickly open up the floor. In case you have any questions, you can post them in the Q&A chat box. I haven't seen any activity there. Just in case you have a question or two, we have just enough time for that. Please post your questions that you want Professor Krishanu to address in the Q&A chat box, please. Okay, and while we wait for some of these questions to come up, I just want to share again, and the Coursera team has been posting the link to our program in the chat box time and again. Uh, Feel free to write to us in case you have any doubts about the program. This is a fully online one-year master's in public policy. This program is fairly unique because it has two tracks. For the students who want to specialize in data analytics and data visualization and, well, data science, there's a data analytics pathway that you can pick after your first half of your learning. So you take some specialized courses in data science, data visualization, econometrics, all of which go towards building very strong capacities to analyze fairly large data and present them effectively. So these are some of the options. Please do check out our program structure. It's extremely interesting how there are two pathways for those who are interested in specializing in data analytics. And I hope some of you will find this interesting and join us for a more detailed learning of public policy. So I don't think we have any questions. Most of the questions, it seems, were taken on the go. Feel free to write to us, and thank you all for joining in. Thank you again, Professor Krishanu, and the entire Coursera team, and Mr. Manish, our admissions coordinator, for joining us. Thank you, everyone, and have a good day, good afternoon, good evening. Take care. Thanks. How quickly can we put this on Coursera?
So Professor Naveen, I'll check with the internal team. However, 2 days of timeline is required. So we will, I mean, definitely whosoever has joined, I mean, the participant will receive the recording of the webinar over the email. And I'll also speak to the internal team to, once the recordings are available, we can also update our website as well.
It'll also be helpful if you could share this link with me. I'd like to post this on LinkedIn as well.
Oh, that will be wonderful. So let me also check with the internal team. I'll connect and I'll also try to figure out to share the link with you also.
Thank you. Thank you.
Thank you, Professor Navin, for joining in today's. Yeah,
Take care. Bye.
thank you.